All right, so back to our uncertainty principle, right? We've got this delta x, that's our uncertainty in position. Right, this m is this mass, and then this delta v is uncertainty in velocity. Right, and so we can see when m is big, the uncertainties can be small. When m is small, the uncertainties must be big, because overall, again, it must be greater than h over 4 pi. So let's think about terms of classical mechanics. So we're talking about big things. So let's say I have this dude, right? He threw this baseball, right? And what we're trying to do is trying to predict, we've got a little target on the floor where this baseball is going to hit. Well, if you know the position and velocity, you can tell exactly where it's going to end up. So you can calculate exactly where it will end up. So if you took physics or are going to take physics, you'll do these kinds of experiments, right? A ball's up in the air, has this position, has this velocity. Where's it going to end up? You can calculate this. It's really not that difficult. And you can go right exactly where it's going to hit, right? So if we've got, this target, you can tell me it's going to hit right at this spot, exactly at this spot. Let's try to do the same thing for a quantum particle. So a small thing. So this is an analogy. Obviously, you can't kind of shrink yourself down that small, but let's say you tossed an electron. Now we have uncertainty in its position and its velocity. We can't know both exactly. And so if we think about kind of where it's going to land on our target, well, we have uncertainty in both. And so we can't tell you exactly where it's going to end up. So we can't know. We can't know position / velocity exactly. Thus, we can't tell where it's going to end up. But our uncertainty is not infinite. We do have some level of certainty. We know approximately the area it's at, and we know approximately its velocity. So we can't tell you where exactly it will end up, but we can tell you where it probably will be. Right, where it'll probably be. So if you're taking kind of look at this type of target, you couldn't tell me exactly where it's going to end up, but you could give out kind of different zones. If you're playing kind of whatever, you could give out different zones. And so you could say there's an X% it'll land here, and a Y% it'll land here, and a Z% chance that it'll land here, right? So what we can't do for small things like electrons and quantum particles is tell you exactly where they are and tell you exactly what their energy is, but we can make probability maps. So we can't tell you exactly where it's at, but we can tell you approximately where it's at.